Okay, we'll go ahead and get going. Good morning, everyone. Thanks for joining our third KeBond webinar. My name is Taylor Krenek, U.S. Sales Manager for Lifting Solutions U.S. Few housekeeping items. We are going to be recording this presentation, so it will be on our website or YouTube channel. We will have a full Q&A at the end as well via the question chat on the side there. And then we will get into our presentations for today. So our agenda for today, we're going to talk about KeBond product overview, its benefits for corrosion applications or benefits for corrosion, friction and wear benefits, how we configure reciprocating rod pump string designs or configurations, servicing for the KeBond product, the application range, and then our initial operational experience in both Canada and the US. So KeBond overview, corrosion fatigue is a very frequent rod string failure mode, especially with continuous rod, where the absence of most of the connections eliminates what's usually the most common failure mode. Lifting Solutions initial coated rod, or EthiFlex coating, has been in use since 2011, with over 6.5 million feet installed across thousands of Canadian progressive cavity pumping wells. This high-density polyethylene coating demonstrated the benefits and durability, but the coating material being HDPE and its design being unbonded limited the application window to low gravity, low temperature, and shallow progressive cavity pumping applications. So how do we go deeper? How do we go hotter? How do we broaden our horizon into the rod pump world? So our second generation KeBond coating is a polyketone blended coating. Its research and development and manufacturing process was completed in early 2023 with an extended application envelope that provides entry into a wide range of rod pump applications. It is a multi-layer non-metallic coating. It's directly bonded onto the endless rod body. It's a thick polyketone durable outer layer, which accommodates significant coating wear before losing parent material. Lots of internal product testing followed by very extensive PCP and reciprocating rod pump field testing in both Canada and the US. There's a QR code down here and links on our website to both webinar 1 and 2, where we went a little bit further into development and testing of the product, if you'd like to go and visit. So kind of getting into the benefits on the corrosion side. So as many know, corrosion is very common in almost every single rod pump application. It can be very detrimental to the condition and integrity of the rod string. Corrosion creates surface damage. It reduces the cross-sectional area that can be an initiation point for cracks, and they propagate under cyclic loading. This potentially leads to failure, fatigue failures, and associated well interventions, and this may necessitate equipment replacement, whether that be the rod string or the tubing. Corrosion is often managed in design systems through service factors that downgrade the max allowable stress, but in return, this typically requires a larger diameter rod or a higher strength rod, and this could limit production. Chemical inhibition may not be as effective with endless rod, especially in deviated directional wells due to the rod on tubing contact, which prevents the buildup of the protective inhibitor layer on the rod surface. KeBond coated rod, or the KeBond coating, fully encapsulates the rod and prevents fluid migration through the coating, which protects the underlying parent material from exposure to wellbore fluids that can result in corrosion or corrosion fatigue failures. Some benefits of the KeBond coating from a friction wear or a surface damage standpoint. So rod on tubing contact and associated friction and reciprocating rod pump systems increase the peak polish rod loads, which elevate rod stresses, and they reduce the minimum polish rod loads or the downstroke weight, impairing rod fall. This interaction between the rod and tubing also creates tremendous amounts of wear, leading to rod parts or holes in tubing. Reductions in friction are typically accompanied by lower component wear, less repairs, less maintenance, sliding wear testing, and various oil and water mixtures. Confirmed lower tubing wear rates with KeBond versus bare endless rod. Wear rates in combination with line tubing are very dependent on the specific lining material. KeBond can also function in some cases as an alternative to line tubing for wear mitigation and directional wellbore profiles, and it has the benefit of being a lower cost and easier wearable component to replace. KeBond protects the rod surface from handling in downhole mechanical surface damage that can initiate points for failures as well. So any surface damage, any nicks on the rod, the coating really protects the rod body from that. So our KeBond string applications or configurations in reciprocating rod pump applications, our KeBond coated endless rod is available in all of our common endless rod sizes. So that'd be 1 1/8 all the way down to 7/8 across all of our grades by extrusion. This can be configured in tapered string lengths, including larger bottom sections in the RRP applications or sinker sections as we call them. Connections, splice, and taper weld areas are protected using several methods that can be applied during the initial string build or at the field level. We have some photos following this slide, but right now we're currently deploying a molded or bonded elastomer sleeves and then also deploying an epoxy coating as well. We're looking into reinforced fabric wrap with a pre-impregnated resin that's currently in research and development. So obviously initiatives are always ongoing to better the weld area. Our endless rod pen ends are a coated MAC 100 pen end. We recommend that the sucker rods, pony rods, any component in the string should also be corrosion resistant or have corrosion resistant coatings to prevent them from being the weak leak in the system. When deployed in directional wellbore profiles, we highly recommend rod rotators to distribute wear around the coating diameter and extend the product life. We would recommend this for bare rod or our coated rod, but especially with the coated rod. Here are two photos. The top photo is going to be an elastomer sleeve, and then the bottom photo is going to be our epoxy weld and pen end coverage. The elastomer sleeve is applied by elastomers wrapped around the rod body and then heated through an oven. And then the pen end for the epoxy weld is much simpler. You can see it's not as robust, but we have success with both of these depending on the area and the wellbore conditions. So we have a great product. We can go deeper, we can go hotter. How do we service it safely, and how do we service it without damaging the coating? All of our equipment on the rigs, all of our equipment in the manufacturing facilities, running pulling processes must safely handle the rod weights without damaging anything. So we have made every single component compatible with our standard servicing equipment. We've adopted a V-shaped gripper pad with serrated profiles. It's a harder pad, which minimizes surface wear and profile changes. And we also recommend, it's super critical to follow our gripper squeeze pressures depending on depth and weight. Special KeBond endless rod clamps and safety equipment. We adopted a tubing style safety to where in the event we were to lose the rod string, the tubing style safety threads directly onto the rod BOP and actually would dig through the coating and catch the bare steel. Fishing operations, we get asked kind of a lot, how do we fish it? It's very similar to a bare rod install in which we surface the top part, a fish pin is welded to the top section, and then sent back down hole with the fishing tool. Not all the time, but sometimes it could require two trips, one trip to strip the coating back and then one to actually latch onto the fish. Damaged coated sections or worn coated sections are typically cut out and the string is rejoined through welding with the appropriate weld area protection. So our application range for this product was defined by our product specs, initially determined throughout product validation testing, and it's currently being verified through the field. Most all of our US reciprocating rod pump field testing conditions are going to be in the upper range of our specifications. Service and related parameters confirmed, but additional runtime is required to confirm some of the operational related parameters. Our experience to date has identified the primary limitation as well tortuosity combined with higher temps as they can accelerate wear and or compromise the coating to rod bonding. So our rod pump operational experience in Canada stemmed from great success over 400 wells in progressive cavity applications with the longest runtime approaching 2 years. So given this success, there is confidence in deploying it. The first rod pump installs in Canada were later in 2023. 6 shallow wells, medium oil, moderately directional, run times from 12 to 18 months, with several cases exhibiting one-sided coating wear, attributed to a combination of wellbore curvature, rough corroded tubing, and the absence of a rod rotator. These trials expanded into additional RRP wells with moderate application conditions as alternative to sucker rods that historically experience corrosion fatigue failures every several months. This exceeded prior run times, approaching targeted 3 times run multiple. Several pulls for pump changes confirmed undamaged rod conditions suitable for rerun. And then product deployment continues into a broader range of RRP application conditions on the lower to middle end of the application range. Our U.S. experience stems from early successes in Canada in both PCP and RP applications. Our first operator in the U.S. began with a 15-well test program at moderate depths up to 5,500 feet. These were mildly corrosive horizontal wells where the pump was landed in the curve between 50 and 60 degrees and upwards of 13 degrees per 100 dogleg severity. The objective here was preventing short run failures due to rod on tubing wear after as little as 30 days. In some wells, KeBond replaced line tubing that was run in the bottom directional portion of the well as a cheaper alternative. Run times are currently 300 to 450 days with 2 rod breaks due to strictly mechanical fatigue, but the coating was still intact. We also had numerous other pulls for pump changes in these curve applications, but confirmed that KeBond had good wearability and it was suitable for rerun as well. This is now considered a commercial success, and we are progressing with additional installs with this client. The second operator began with a 10-well test program in deeper, more unconventional applications up to 8,700 feet, more aggressive downhole conditions, 130F, 40 API. So this is more at the top end of the product application window. Base run times range from 50 to 250 days, and our target runtime was essentially the previous 2 runtimes averaged, and then we wanted to double that. Actual results are all currently exceeding the base, 8 of 10, and in some cases over 5x. This is also considered a commercial success in this client, and we've expanded our install base to 26 wells to date. Several other small RRP field trial programs are in progress over a range of applications, some under fiberglass, some on the West Coast, some in PC pump wells in the US. So essentially trying to establish KeBond benefits in a wide range of applications. So in summary, KeBond is a proven solution for wells that have high failure rates due to corrosion fatigue on the rod string, and then severe deviation experience and increased mechanical friction resulting in holes in tubing or rod parts. Our current install base in the US is going to be 71 wells, primarily RRP, and in Canada it's going to be 497 or close to it. Again, on that side, it's going to be primarily a progressive cavity pump. So a little bit more dominant RRP in the US than Canada, but both regions have a fair share of both applications. So we'll go ahead and open this up for Q&A. Okay. Yeah. So what style of rod rotator is recommended? We recommend a slow gear, a one-way ratchet style. That way there's no backspin. Still, we think it's very hard to get rotation to the pump in some of these highly deviated wells, but we've had our most success with a slow gear, a one-way style rod rotator. So looks like another one here. Why is there a depth limitation? So that's a great question. We get asked that all the time. It essentially comes down to a function of overall string weight. So depending on the configuration of the tapers, we're limited to about a 20 to 22,000 pound overall string weight. That's due to the coating being a multi-layer coating between the tie-layer bonding agent and the polyketone. We just don't want to extend over that 22,000 pounds quite yet, mainly because we don't have the service data to say that we can safely go deeper than about 8,300 feet. So another question, is there going to be a next generation coating? Absolutely. It's in research and development right now. We're looking at a Gen 3. We don't have a name, can't really share specifics on material, but the goal is to be able to go deeper and hotter. So we are looking at expanding our operating envelope with our Generation 3 coating. So another good question, coating thickness. The average coating thickness is going to be probably 2.5 millimeters, somewhere around there. I think the minimum coating thickness is around 2.3 or the average. So 2.3 to 2.5 is going to be what the KeBond coating thickness is, I think, with a max of 3 millimeters. So another question, can you strip the coating off the rod? That's a great question as well. We get asked that all the time. Our first generation coating, you can because it's unbonded. Unfortunately for this product, you cannot strip the polyketone or the KeBond off of the bare rod. So another good question, can you partially coat the rod string? Definitely. So that the pads that we showed previously in the presentation, the V style with the serrated profiles, those pads can pull both bare endless rod and coated endless rod. And so there's no need to change pads or chains. We can coat, if you have an area of deviation down low, if it's up high, if you own bare rod already and you're having failures in another section, we can most definitely partially do coated strings or hybrid strings, as we would call them. So another question, do we have some information to share in terms of reduced polish rod load or amp draw on pumping units when running KeBond versus bare rod? Um, we do. I can't really share that data with you online. If you'd like to reach out to us directly, would be more than happy to kind of get into the weeds on what we're seeing. So another question that I missed here, what is the max temperature of the KeBond coating for high temp reservoirs? Currently right now we're at about 180 F. So that next generation coating, we're looking to go, well beyond 200, but currently KeBond is 180. Sorry for missing that. Our field patch kit's fully available in all areas now. In the Permian, we have one sleeving unit that goes out to the field. I can't really speak for the Canadian business unit, but in the US, we're only running this in the Permian just strictly because of depth and temp, and also on the West Coast. But Permian specific, we have just the one sleeving unit, but it is available and field ready. Okay, well, I think we'll bring it into a closing here. Again, just as a follow-up, this has been recorded. The QR code, the links will be available on our website for our YouTube channel. We also have the link for a paper that we did recently at the Southwestern Petroleum short course for some KeBond test studies you may find interesting as well. And then we are going to have another webinar here in the fall that kind of goes into more of actual real world results. We'll get into the weeds on kind of some of these questions, like some that were asked as far as peak polish reduction, amp reduction on the pumping units and whatnot. So that'll be the webinar in the fall. It'll kind of be, like I said, a little bit more results driven. And then otherwise, we thank you guys for the time and hopefully see you next time.